Good morning, students. Welcome to the live session. So, in yesterday's class, in last live class, I have discussed with you about acids, bases, and salts, especially about their reactions. Right? Acids reacts with metal carbonates, metal hydrogen carbonates. So, with them, simply they are going to form acid base. Sorry. Here simply they are going to produce by the reaction in the activity number 4. Activity number 4, salt, water, and liberation of gas. It may be with the metal carbonate or with the metal hydrogen carbonate. So in the both, just they are producing two common products. Salt may be changes, but two common products, water and carbon dioxide gas. So here testing of carbon dioxide gas, we have observed with burning mastic isolize lime water test. So lime water turns into milky white or that burning mastic put off, both indicating us same thing, liberation of carbon dioxide. Next, activity 5 also discussed. About activity 5, simple, it is a reaction between acid and the base, producing neutral, salt, and water. So here, if the salt is neutral by the acid and base reaction, in which reaction that neutral salt produced by the acid and base reaction is called a neutralization reaction. Neutralization reaction. So here, similarly, in the activity 6 also, you have observed that about a reaction of acid with metal oxide, reaction of base with non-metal oxide, reaction of acid with metal oxide, reaction of base with non-metal oxide, that both are giving you commonly salt and water. So here it is similar to neutralization reaction, but it may not produce always neutral salt. Remember the difference, right? Here it may not produce always neutral salt. Here, depending on the neutral salt, we are naming that reaction as a neutralization reaction. Okay, so focus on that. From the activity 6, it is similar to activity 5, but the reactions are observed here: acid with metal oxide, then in the next one, base with the non-metal oxide, base with the non-metal oxide. So both together commonly giving you the salt and water as products. Next, activity 7 also discussed. What is activity 7? Simply about electrical conductivity of liquids. That simply a liquid by the acid or maybe by the base conducting the electricity. In the remaining cases, we do not observe the glowing of bulb. So for this, just here we are collecting the several materials as you see on the screen. Here glucose and alcohol also taken. That glucose and alcohol do not produce any ions. Yesterday, I have shown you this activity, right? So in this, simply you are taking one plastic beaker, making 2 holes at the bottom and fixing 2 electrodes in this, right? Then you are giving the connections from the bottom, but I am taking glass beaker, I am giving the connections from the top only. Here, from the top, you are connecting 2 wires from 2 different electrodes to the AC plug to the bulb. So one of the end black colored wire is connecting to the AC plug, one of the terminal, then a red wire from second electrode to the bulb terminal. Then this AC plug second terminal and bulb second terminal are connected directly. So in this you can arrange the switch also. So that switch, if you on or before adding water, does it glow? Do not glow. Then adding the water into this, right? So electrodes are connected. Next, adding distilled water. So fill the beaker with distilled water. Then switch on. What do you notice after filling the distilled water? Again, still the bulb do not glow when you switch on. Still the bulb do not glow. Then here I am adding liquid solution, aqueous solution of acid, right? So that is suppose here dilute HCl. Then switch on the bulb. Then what happened? Bulb glow. So did you get any difference in these two cases? Distilled water does not glow the bulb, but with the dilute HCl, bulb glow. So current passing through the circuit. We know to pass current through the circuit, we need closed circuit actually. When you observe clearly that electrodes are not connected, not closed, but they come in contact with the liquid solution here. They are coming in contact with the liquid solution here. So the difference is this one. So here HCl helping that electrodes to come in contact. So this liquid must be act like a electrical conductor, right? Liquid electric conductor. So that make the electrodes to come in contact. So making that circuit as closed one. So then only it is acting like this bulb is glowing. So with the dilute HCl, bulb glow. The next replacing that with glucose. Then switch on. What happened? No response. No observation of this glowing bulb. Then replacing that solution again with alcohol. Then again switch on. Does not glow. Next, filling that with NaOH solution. Then switch on the key. What happened? Again the bulb glow. The bulb glow. So simple. Here also we can notice that liquid is acting like an electric conductor. That liquid is acting like electric conductor. So you understood very well about the electrical conductivity of acids and bases. So acids and bases are producing ions. Acids and bases are producing ions. So similar activity we are conducting to know about the ions only, but the difference in this, we are not depending on the current. So without depending on the current, do you see producing of ions? Did you find? So that we are learning in the activity 8. So here same ions production, but that acids produce ions only in aqueous solutions. That means in the presence of water. Aqua means water. So aqueous related to the water here. So using water. So in the water only are they producing ions. That you have to understand. Then look at about that, how to conduct, right? So here simply, what is our aim? To produce ions or to understand about the production of ions without using any electrical current here. Activity 7, using electrical conductor circuit, using current, you noticed producing of ions by the acids and bases in the water. Okay, now without using electric current, right? Then notice production of ions. So here to observe the ions production, we are conducting this activity. So here I mentioned clearly no use of electricity in this activity. So we are not depending on any other electric sources here. So on which we are depending? So on which we are depending, or here simply we are taking one salt, right? Salt and sulfuric acid. So directly, if you take any water acid, what happens, sir? No, here without water I have to observe. Without water I have to observe. So that's why myself I am trying to produce acid in the form of gaseous. So in gaseous form I have to produce an acid. So for that I am selected NaCl and H2SO4. What happens if a salt is added to sulfuric acid? So here look at, simply a metal is present. A metal is present. So that metal will react with the acid. As we learned in the lab activity, acid reaction with the metal. So H2SO4, sulfuric acid, NaCl containing a metal in it. So sodium chloride, mineral is there. So Na react with this. So automatically it produces salt and liberates gas. Produces salt and liberate gas. Students, are you able to see the screen or not? I don't know. If it is clear, message me. If not clear, also send your screenshot. If it is not clear. Okay, right. So here simply this metal displaces hydrogen from it and forms an acid salt that is in the form of gas, HCl gas, right? So that H combined with the Cl and comes out as HCl as gas here. So you are able to produce HCl in the gaseous form. Then what about remaining product is? It is Na2SO4. Na2SO4. So this is a salt which is available in the form of liquid. In the form of liquid. So here a liquid is produced. A liquid is produced and the gas is produced. What is that gas? HCl. We know HCl is a acid. So does it produce any ions or not? We can observe in the aqueous water, in the presence of water. So NaCl and sulfuric acid is taken. Along with that, we are taking to conduct this reaction test tube, rubber cork, delivery tube. So these are materials required here with that chemical substances. So also I am collecting blue litmus paper. Why? To test the nature of the gas. So which gas we are going to produce? HCl gas. We know that. Then HCl behaves as acid or not? That we are testing. So blue litmus paper is enough for me. Blue litmus changes into red in color. That is indicating the nature of the substance as acidic. So we know HCl is acid. HCl is acid. So here HCl is acid. Then that acid is behaving as acid or not? That means affecting the litmus paper or not. So now double hole rubber cork I am going to take to insert one funnel and the other is delivering tube. The next we will require thistle funnel to insert into the double hole rubber cork as delivery tube also, right? The next dropper we are taking. Why? To drop acidic solution, because we are not handling them. They are maybe harmful, corrosive in nature, so damage your skin. So that's why we are depending on dropper, transferring the then here process. So I'm not mentioned a few materials here. Then what are that materials are here? Simple, look at them here. They are here delivery tube. One is delivery tube. Okay, delivery tube. Along with that, you are required one chemical substance, that is anhydrous calcium chloride, CaCl2, calcium chloride. Why, sir? Suppose how you are feeling today, it is cloudy, and maybe it gives you more vapor in the air, moisture. So maybe it is humidity, right? Due to humidity also, the vapor increases in the air. That maybe makes your HCl gas somewhat wet. So make it dry. We are using anhydrous calcium chloride. So take care about this, right? So you need anhydrous calcium chloride. Okay, we are collected all the materials. The next in the procedure, just you need test tube first. So we are taking a test tube. I'm taking test tube into my hand. Then what I have to do? Just I have to take a rubber cork. I have to take a rubber cork. So taking rubber cork, then what we can do here, simply I can fix delivery tube, thistle funnel, and one more we are taking delivery tube, thistle funnel. Okay, so before that I can add acid into this. So fill the test tube with certain amount of acid, sulfuric acid. So take certain amount of sulfuric acid, then stop adding up acid into the test tube using the dropper. So I use a dropper for adding sulfuric acid into the test tube. Directly don't use the bottles. Maybe that spills on your fingers. So that's why I am suggesting you to use dropper, right? So we can drop directly into the, inserting the dropper into the test tube. Then we can use the pressure that to drop the acid. Okay, sulfuric acid is taken into the boiling tube or test tube. The next duty here, take double holed rubber cork. Take double holed rubber cork. Do not fix directly, right? Before fixing that rubber cork, you have to arrange thistle funnel and delivery tube. So this is called a thistle funnel here. This what you observed, that is called a thistle funnel. That can help you to add something, solid material or liquid material, into the liquid substances without allowing the gases delivered through this, right? So one more hole is there that can be fixed with the delivery tube. So this thistle funnel we can insert into the liquid solution taken into the test tube. So what that solution taken in the test tube? Sulfuric acid. So immerse this thistle funnel glass tube into the liquid solution. So fix this arrangement to the boiling tube mouth. So that can be fixed into that. See, look at here, these thistle funnel tube inserted into liquid solution. So this thistle funnel will not allow the gas to escape through this its mouth funnel. So through this, they will not allow the gases to escape. They won't allow. So this is the advantage using in thistle funnel, right? Maybe you got clarity about this thistle funnel. Why do we need? Directly start taking the boiling tube and adding the salt. What happens? So immediately that gas may be escaped. Maybe a small amount of gas liberated, you won't capture that. You won't trap it. So we have to trap the gas. So this arrangement, thistle funnel and delivery tube using double holed rubber cork will trap the gases in the boiling tube. That can be allowed only through this delivery tube. If you close this delivery tube also, you can trap the gas inside, right? Then after adding this sulfuric acid, we have one more substance. This is here anhydrous calcium chloride, where we have to use that. Actually, this one not to drop into the sulfuric acid. We are observing the reaction only between sodium chloride and sulfuric acid, not between the sulfuric acid and calcium chloride. Just it is used to unweight. That means making dry that liberated gas. So that liberated gas passes through delivery tube. So I have to dry this gas before delivering through this tube. So I can put that or place that anhydrous calcium chloride in the delivery tube. While passing the gas, it can be dried. So look at, I'm going to place it in the delivery tube. So slowly one substance inserting into the delivery tube, that is placed here. Look at that. I'm showing you with an arrow. Here, simply I placed one substance. That is what? Anhydrous calcium chloride. Anhydrous calcium chloride. What is the purpose of using anhydrous calcium chloride? To dry the gas. Make it dry. That gas passes through the delivery tube. In the delivery tube, we are using a special substance called anhydrous calcium chloride that absorbs the moisture from the air. So that's why it is called as anhydrous, making dry, absorbing from the gas. So it can absorb, then make it dry. Okay, we placed anhydrous calcium chloride. Then observe the reaction now. What is the reaction? Sulfuric acid and sodium chloride reaction. So only sulfuric acid is added into the delivery tube, boiling tube. Then what to do? Drop the NaCl crystals, solid, through the Thistle funnel. So take fine crystals or powder of the sodium chloride to drop that through the Thistle funnel. So slowly I am dropping that. Look at, drop it into the H2SO4. Then observe what happening in the boiling tube after dropping NaCl into that. See, slowly the bubbles has started in the boiling tube. That bubbles are indicating us liberation of gas by the reaction of sulfuric acid and NaCl. So remember that gas started liberating. So that can pass through the delivery tube. So here, just I am pausing this reaction, right? I am pausing this reaction here. Just I'll give you some notification, important notice here. What you have to observe. What you have to observe. So here simply I am reversing this one. Okay, not dropped HCl. When you drop HCl into this, immediately what happens? That reaction maybe takes place between H2SO4 and the salt which you dropped. What happens? It liberates a gas. So this gas we are testing. For what purpose we are testing? Is it behaves as acid or not? Right? That HCl is gas, we know. Right? HCl is what? Its behavior decided as in the activity 1, acid. Using blue litmus paper, changed into red in color. So change in the blue color litmus paper into red color, giving you idea about the behavior of substance as acidic. So does it affect blue litmus paper or not? That we have to understand here. So testing that liberated gas with the blue litmus paper, does it affect or not? Okay, so we are using blue litmus paper as that available in the laboratories. So we can call it as dry blue litmus paper. Then observe, does it affect or not? If there is no effect, make it wet. Now we are using wet blue litmus paper. Make it wet. So wet blue litmus paper we are using here. So that wet blue litmus paper will affect that litmus paper or not. Right? So this is, you have to observe carefully. So before dropping the NaCl, you have to get ready with the dry litmus paper and wet litmus paper. Only one color, that is blue litmus paper. Dry blue litmus and wet blue litmus. So now I'll continue this animation. So look at dropping the NaCl into that. So that NaCl reacts with sulfuric acid, and we are observing slowly that bubbles released in this arrangement. Then that gas transferred through that. See, here it is delivering through the delivery tube. So before coming out, they are passing over the surface of anhydrous calcium chloride. So it can absorb the moisture present in the gas. Then it is allowing only dried gas. So this is dried gas. Then I brought a blue litmus paper, dry blue litmus paper. Now I am supplying HCl gas onto the dried litmus paper. So that gas is passing but not affected. It remained in the blue color. Then what I can conclude? Does that behaving as acid or not? So not affected. We cannot decide that gas is acid because it is invisible. We know name, it is as HCl by the reaction. But nature will be tested, decided by this observation only. So no effect on the dry litmus paper. Blue doesn't affect it. Okay, you can bring red litmus paper also. No effect. So can you call this HCl as a neutral substance? No. Already we know that HCl dissolved in the water behaving as acid, because there we are using distilled water. We know distilled water is neutral. That distilled water changed its nature towards acidic because of adding of HCl only. So it is maximum because of HCl only. So I got an idea. Maybe that HCl giving its nature as acidic in the presence of water. So that's why now I am changing my ideology towards water. So I can bring now that litmus paper making wet. So that HCl gas not affecting the dry litmus paper. So now I am getting one more litmus paper which wet. See here, I am showing you different color here. It is wet. Then upper portion dry. It is dried. Right? This is only wet portion. So that's why I shown different colors, somewhat dark. If you keep that something object colorful into the water, it becomes more dark, right? So that's why I'm showing you here different in colors, somewhat dark portion. So now pass the gas over this surface. So continuing that passing of gas onto the wet litmus paper. Just wait for 1 or 2 seconds, few seconds, then supplying the gas continued. What happens? Observe. See here, then the gas is passing on the wet litmus paper slowly. That is affected. Blue changed into red in color. Blue changed into red in color. So automatically what we can say? The gas passed onto the surface is HCl. Onto the surface is HCl. So we can decide here that gas is behaving as acid. That gas nature decided as acid. But we know dried gas supplied and dry litmus paper does not affect it. We passed that gas onto the wet litmus paper affected. So there is a difference. So here, whatever it may be, any substance that can behave as acid, where? Only in the presence of water. Only in the presence of water. So here, what happened actually? When you get a wet litmus paper, when the blue litmus paper wet with the water, so making wet, what happened? That is only showing the nature of the solution. So we can decide simply, maybe something is happening between the gas and water. So maybe they are reacting. Maybe they are reacting. So that we have to understand. So here, the reactions are here. The reactions are here. When the sulfuric acid and NaCl are together in the test tube or in the boiling tube, they can react and giving you HCl and simply solution, aqueous solution. That is, sorry, it is sodium sulfate. Mistake. Na2O written. Na2SO4. That is Na2SO4. So sodium sulfate solution in the form of liquid remains in the test tube. So Na2SO4 HCl. HCl is a gas, bubbles passing the onto the surface, right? So in the liquid, bubbles produced, it is indicating the gas. Okay. So here HCl gas, then combined again with. So conclusion we derived. I'll give you that ions production in the next reaction. So conclusion, what we can derive the conclusion here? Simply HCl is not an acid with dry litmus paper, and HCl is acid with wet litmus paper. That I decided here. So simply I derive a conclusion that HCl gas behaving as acid only in the presence of water, but not in the absence of water. So dry litmus paper not affected. So that's why I decided HCl is not an acid. Then with the wet litmus paper, I noticed blue litmus changes into red in color. So I decided HCl is gases. So one only behaves as two, sir. No. Here the observation point, main thing is to understand is that gas behaving as acid only in the presence of water. So that is the conclusion from this activity. Then again, we are going to observe one more thing. What happened when acid diluted? That means simply HCl and the blue litmus paper, wet condition. So that is happening something here, interaction between them, reaction between them. So here, then we can say that ions are produced. How you decide, sir? Simple. Activity 7. What I noticed, acid added into the distilled water. Distilled water itself, bad conductor. When acid added, behaving as electric conductor. So simply, because of ions only, that electric liquids conducts electricity. Liquids conduct electricity due to presence of ions. That ions are due to what? HCl. So I am able to decide ions produced by the HCl only in the presence of water. So ions produces. What type of ions produces? They can produce H plus ions. They can produce H plus ions. But hydrogen ions cannot exist as bare ions. Alone cannot exist as single. Bare means alone. So they cannot exist as bare ions. What happens? Simply they can combine. They are going to attach with the water molecule. So H plus combined with the H2O. So here HCl we added into the water. So when HCl added into the water, they can produce H plus ions, right? But that H plus ions immediately combine with what happens here? See here, actually they can add it into the water. They give you partially H plus ions and Cl minus ions. This H2O also can give you H plus and OH minus ions, right? So here simply that give you here HCl. Okay, that is not given in your 10th level. Directly what they have given here, simply from this you are going to notice here H plus ions will be produced by the acid in acidic medium. That H plus immediately combine with this H plus and H2O, giving you ice H3O plus ions. Right? Then remaining is Cl minus ion. In the water, not in the big test tube. That gas passing onto the wet litmus paper, this is happening actually. H3O plus ions produced. So you are writing H plus or H3O plus. They can understand. Oh, H plus will not exist as a bare ion. That's why they written H3O plus ion. So while writing in the exam, H plus and H3O plus both you can use. Right? So now that H plus ion is combining with the H2O molecule and giving you H2H3O plus. So this we have to mention. Then if you add a base into the distilled water, or if you conduct that activity with the base, right, in dried condition, also we can observe ions produced. What ions? OH minus ions. NaOH combining with the water and giving you OH minus ions and Na plus ions. So that OH minus ions will affect the litmus papers. So this activity not given, only we are testing on acid, right? So simply one more example. If you take potassium hydroxide, what happens in water? They can produce K plus and OH minus ions. So simply one more we are able to conclude about acid and bases behavior, that acids or the substance which can produce H3O plus ions in the water are said to be acids, which can produce OH minus ions in the bases, in the water called bases. So this is according to Arrhenius theory. Arrhenius says the substance which can produce H plus or H3O plus ions in the water named as or defined as acids. The substances which can produce OH minus ions in the water decided as bases. Right? So this is Arrhenius theory. So this is happening actually when an acid or the base added into the water, diluted. So that will learn. Then here going to the activity 9 here. What is activity 9? So simply in the previous discussion, in this I said what happens when acid diluted. Means what? Simply acid and water we are combining. I'm not saying the order in which you are adding other. I'm not mentioned. Just I am saying acid added into the water. So here acid adding into the water or water adding into the acid. Both are same, combining. But which is the right way, correct method? Which process is safe? So here simply that we are learning in the activity 9. What do we observe when water is mixed with the acid or the base? Or acid mixing with the water or the base with water. So any manner, but which order is correct, which is adding into the other. That is the right way. We are deciding. So here simple, the process of dissolving an acid or the base, right? Acid or the base into the water is an exothermic process. That exothermic process means liberation of heat energy. It leads to produce energy liberation, releasing of energy in the form of heat. So the process of dissolving an acid in the water is said to be exothermic process. What happens when acid added? So releases energy. So always we are suggesting must be add acid into the water, but not water into the acid. Right? So adding acid always into the water. So clearly mentioned, acid must always be added slowly to water. Then one more we are doing, stirring that liquid while adding, right? While adding, stirring the water constantly. That is the correct way. what happens, sir, if I reverse this? Adding water into the acid. Highly exothermic. Highly exothermic. That liberated heat energy maybe breaks the container due to its or maybe that spills out. That acid may spill out. If that acid may fall on your skin, on your face, that corrodes your skin. That corrodes your skin, burning. Right? So that's why acid must always be added slowly to the water with constant stirring. So look at that. I am continuing that process, how to do. Right? Simply, you can take a beaker. You can take a beaker, then add distilled water into the beaker. Fill the beaker with distilled water as you required. Okay. Fill distilled water into the beaker. Then use a stirrer. That is glass rod, not the metal stirrer. Why, sir? We learned already in the lab activity, metal reacts with the acid, produces salt and water, salt and hydrogen gas. Right? So, to avoid that reaction, unreacted material, right? So that we are taking a glass rod after filling that. So, glass rod is placed into the beaker. Glass rod placed into the beaker. So then adding acid drop wise, not all the quantity at a time, small quantities as drop wise. So while you are dropping, continuously stir it. Look at, I am adding that acid, right? I am adding that acid and continuing stirring. Look at that, right? So here adding and stirring. Adding and stirring. So again, I'm showing you. See here, dropwise adding acid into the distilled water and stirring continuously, constantly. Don't increasing, not decreasing. Do not change the speed of stirring also. So like this, you can continue. So what I added, suppose HCl, say it is as HCl. So what the solution here? It is not distilled water. That solution is what? Diluted HCl. So this is the process of diluting. Sir, if I reverse, what happens? It may spills or break this glass container. So that is very dangerous. Because of highly exothermic, it is happening. Right? So now here we are observing one precaution symbolically on the containers of acids or the base, as you see this one. So that something dropping on the hand. So what happened? Where the drops are falling, damaging the skin. Look at on the metal. See here, this portion corroded, damaged. So that acids are said to be corrosive in nature. So that's why we are getting a symbol with the triangle filled with yellow. Then symbolically inside you can observe these symbols only. So what they are indicating us? What they are indicating us? They are indicating us simply about corrosive in nature. They are corrosive in nature. So warning, corrosive. What does it mean? The triangle symbol inside, that a dropping of something on your hand or on the metal surface, corrosive in nature. This is the warning symbolically given. Why it is happening? It is exothermic process. Acids are corrosive in nature. Bases are corrosive in nature. If I say this point, you may get one doubt in your mind. That is, all the acids are corrosive in nature, sir, because we are eating some acids with the food. So all the acids are not corrosive in nature. Some of them are corrosive in nature. We are able to decrease its strength. Decrease its strength. Why? Decreasing to use in different processes. Use in different processes, right? So diluting process will change its strength. Corrosive maybe becomes non-corrosive by dilution process. How to dilute that? So as you learned in the activity 9. Right? So strength of the acid will be decided symbolically here. We learned in the second lesson using the symbols dilute or concentrated to give the strength of the substance, concentration. So if it is highly, strength is more, so we can write as C1CONC, concentrated. So its strength is high, corrosive in nature. Diluted, non-corrosive. Diluted, non-corrosive, but give you burning sensation something, right? Gives you burning sensation. So that we are understanding from the activity 9. So now here about activity 10. Already I mentioned what maybe we are going to learn in the activity 10. So simply dilution process I said. So you are able to decrease the strength of the acid or the base. So what is actually strength? How do we decide the strength of the acid or the base? Right? So you are giving something strength, it has. Is it measurable? If measurable, how do we measure? That we are learning in the. So one is related to the other. One is related to the other. How we can? Right? So activity 8, sorry, activity 7 we learned, 8 we learned, 9 also we learned. In the activity 8, electrical conductivity, 8, 7 is electrical conductivity, 8 is ions production, 9 is about dilution process. It with the noun acids and with the noun bases, right? So what is our aim is to know about the strength of the acid or base, to know about the strength of the acid or the base. So here, to decide the strength of the acid or the base, we required few materials. What the materials are here? Hydrochloric acid, acetic acid, 2 acids, right? Hydrochloric acid, acetic acid. Not to actually, we have to test all the materials, but directly we are going to observe only 2 substances towards acidic in nature and 2 substances towards basic in nature. One is sodium hydroxide and the other is ammonium hydroxide. 2 acids, 2 bases. With that, you required here electrodes. As you conducted in the 7th activity, the same process we are following here in the activity 10. So electrodes, bulb, then connecting wires, 230 volt source, plug, AC. Then what is the procedure? So here, acetic acid, hydrochloric acid, sodium hydroxide, ammonium hydroxide, you can collect them with the available strengths directly in the laboratory. We are not diluting them, right? So IC is available from the lab, you are collecting. Then procedure. So how to conduct this process? How to conduct this process? So in the process, here see, electrodes, bulb, wires, etc. are given. So also you required few materials along with that. What? Beakers. How many? 1, 2, 3, 4. So 4 beakers needed and 4 sets of electrodes needed. Sir, 1 set only available. No problem. You can conduct this activity by using only single set, but make it dry before going for another. Make it dry or just make it wet using a dry cloth. Clean it. Okay, so beaker needed. Then completing the process, connecting the circuit first, right? So connecting the circuit and placing that electrodes with the circuit, open circuit. That means electrodes come in contact only in the presence of liquid, right? So they can connect. Then they can pass electricity towards the bulb, ions, right? By the liquid conductor only. So what to observe here? What are the observations? Where I have to focus? What are the precautions, right? So precautions are here. Simply, electrodes should not touch each other directly. We have to use open circuit. We have to use dropper. Do not touch acid or the base. Do not smell them. Do not taste them. So these are the precautions we are following. Observations. Mainly you are focusing on the bulb intensity, brightness, bulb intensity. On the brightness of the bulb you are focusing, right? So with the brightness, how we can decide the strength, sir? How we can decide the strength? So that is main observation point. So this process I will continue in our next class, right? So I'm session, ending this live session at this point. This process and observation, finally conclusion will be given in the next classes about this process. See here, be clear that everything we are ready to conduct this activity will be discussed on next class